Hi class, welcome to the first lesson in Unit 6. In this lesson, we are going to begin our study of moles and stoichiometry. By the end of this lesson, you should be able to determine the number of atoms in a molecule and calculate the molar mass of a compound. Make sure you have a Regents Chemistry reference table and calculator out and available as you are going to need it for this lesson. Let's get started. Stoichiometry is defined as the study of the amounts of reactants and products in a chemical reaction, or the study of chemical recipes. It studies how atoms combine to make formulas and how matter cannot be created or destroyed during a chemical reaction.
In this unit, we are going to study the mole. The IUPAC abbreviation for the mole is MOL. A mole is a unit of measure that gives a specific amount of particles. The number of particles in a mole is 6.02 times 10 to the 23 particles. But what we're going to focus on today is a mole is also equal to the gram formula mass of any compound. The molar mass, also known as the gram formula mass, is the mass of the formula expressed in grams. The units for gram formula mass are grams per mole. The molar mass of elements is reported on the periodic table. In order to calculate the molar mass of a compound, count up the atoms in the compound, look up the masses for each atom on the periodic table, multiply the mass by the number of atoms for each element, and add up the total mass. So when we're looking for the molar mass of an element, all we have to do is look on the periodic table. You may round the molar mass to the tenths place. Make sure that you examine the hundredths place so you properly round to the tenths place. So what is the molar mass of iron? Well, 1 mole of iron equals 55.8 grams. What is the molar mass of copper? Well, copper is element number 29. Copper has a molar mass of 63.5 grams per mole. Now, when you're finding the molar mass of a compound, you'll need to have the compound formula. So when we are examining the molar mass of water, we look at the formula for water, H2O. So we take the mass of hydrogen, 1.0, and multiply it by its subscript 2. We add that to the mass of oxygen to get a total molar mass of 18.0 grams per mole. What is the gram formula mass of calcium chloride? Well, again, you need to have the formula, and here we have to make sure that we properly round each mass to the tenths place. So we add 40.1 for 1 calcium plus 2 times the mass of chlorine, which is 35.5. The gram formula mass for calcium chloride is 111.1 grams per mole.
In order to calculate the gram formula mass of a substance, it is important you remember how to interpret chemical formulas. The first part of a chemical formula we will discuss are subscripts. Subscripts are the lowered numbers that go behind an atom. In this example, we have 2 hydrogen and only 1 sulfur. If no numeric subscript is given, it is understood to be 1. Coefficients are used in chemical formulas to signify the number of those formula units. Coefficients are large numbers placed in front of the formula. In this example, 2 dihydrogen monosulfides would have 4 hydrogens and 2 sulfurs. In some formulas, you may encounter parentheses. Parentheses are used particularly for polyatomic ions found on table E. In this formula for barium hydroxide, we can see that the subscript 2 is outside of the parentheses. When you have parentheses, the subscript outside applies to all of the elements within. So barium hydroxide has 1 barium, 2 oxygens, and 2 hydrogens. Now that we've talked about how to read a chemical formula, let's talk about the compound aluminum fluoride. Aluminum is a metal and fluorine is a nonmetal. When they make a stable ionic compound, their total charge is 0. So there is 1 aluminum ion and 3 fluorine ions. To calculate the gram formula mass, we will need to use our reference table. Our reference table gives the average atomic mass, or the average mass of every naturally occurring isotope for each element. The average atomic mass is given to varying numbers of significant digits. To calculate gram formula mass, it is okay to round to the 10th place. Make sure you are rounding and not truncating numbers. So aluminum's mass rounds to 27.0 grams. And fluorine's mass rounds to 19.0 grams. Notice for fluorine, although it says 18.99, we do not truncate the number, but instead we round. Since we have 1 aluminum but 3 fluorines, we're going to have to multiply the 19 times 3. This is where you'll require your scientific non-graphing calculator. On your next exit ticket, 1 point can be earned from coming to class prepared with the proper calculator. So when we use our calculator to carry out the multiplication, we see that 3 times 19 is 57. If we add that mass to the mass of our single aluminum, 27, we can get the total mass of our substance to be 84. Now, because we had a decimal point in our masses, we will keep it. Now, when we report an answer for gram formula mass, we can either use the units, atomic mass units, a derived unit where a proton is 1, a neutron weighs 1, and an electron weighs nothing. Or you can report the same number with the units of grams per mole. A gram is a unit of measurement we use in the lab, and a mole is the quantity of particles that you will need to have exactly a measurable number, in this case 84 grams of the substance. We'll talk about moles later. Let's look at this next example. This is a polyatomic ion. It is not binary. You can see that there are 3 different elements. Using reference table E, this is called sodium sulfate. In 1 unit of sodium sulfate, we have 2 sodium atoms, and we have 1 sulfate ion. A sulfate ion is a sulfur atom and 4 oxygen atoms. We can use this information to calculate gram formula mass for sodium sulfate. So here, to calculate sodium sulfate, we can see that we have 2 sodium atoms, 1 sulfur atom, because when there is no subscript provided, it is understood to be a subscript of 1, and 4 oxygen atoms. When we carefully look at our reference table, we can see that the gram formula mass of sodium is 23. The formula mass of sulfur, which is recorded to 32.06, rounds to 32.1 when rounding to the 10th place. An oxygen's mass of 15.9994 rounds to 16.0 to the 10th place. When we take these numbers and add them together, we get a final mass of 132.1. Now we're ready for our final example. This is calcium nitrate. One clue that we have a polyatomic ion found on reference table E are the presence of parentheses. So in this formula, we have one calcium atom and two -1 charged nitrate ions. Nitrate has one nitrogen and three oxygens, but since we have a 2 outside of the parentheses, we need to make sure that we have two nitrates. So here we have the elements calcium, nitrogen, and oxygen. There is one calcium. When we distribute this 2, there are 2 nitrogens and there are 6 oxygens. If you look closely on your reference table, you can find that the mass of calcium is reported to be 40.08. When we round to the 10th place, the mass of calcium averages to 40.1. Nitrogen averages to 0.0 and oxygen averages to 16.0. Once we take these numbers, we can place them into our calculator to find the total. You can see that the gram formula mass of calcium nitrate is 164.1. We may report our answer in either atomic mass units or grams per mole.
So by now, you should be able to determine the number of atoms in a molecule and calculate molar mass.
As a summary, there are two different types of numbers in chemical formulas. There are subscripts, which are small numbers written after an element symbol, and there are coefficients, which are large numbers written in front of the total compound. The subscripts tell us the number of atoms in a formula. Here we have the chemical formula for calcium phosphate. So the first thing we want to do is examine the subscripts so we can determine the number of calcium, phosphorus, and oxygen atoms in the compound. Recall that the subscript 1 is never written but is always understood. So looking at calcium phosphate, you can see that phosphate, the polyatomic ion, is written in parentheses. That means that we actually have 2 phosphate units. 2 phosphates have 2 phosphorus atoms and 8 oxygen atoms. Additionally, there are 3 calciums in each unit of calcium phosphate. But the coefficient of 3 means that we have 3 calcium phosphate units. So we will have to distribute this 3 to each and every atom, meaning there are 9 calcium, 6 phosphorus, and 24 oxygens in 1 unit of calcium phosphate.
This concludes lesson number 37. Make sure you've taken good notes and bring them to class. This way you can add to them and revise them. Write down any questions you have and bring them to class. That way you can answer them in your notes and you can ask them to the class. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack